Welcome to the CodeMe channel. In this video, I'm going to talk about how files are saved on the disk, how text or anything is stored on the disk. And you would think that if you just type in some text, letters, whatever, numbers, then they would be saved on the disk as those letters and exclamation marks and punctuation and whatnot. But the reality is different. The reality is that everything is just numbers. So let me show you and let me explain this. Here is the file. Here is the content. Okay, so there's the command line, and I'm showing you it on Linux, but that's basically the same on Windows with slight differences. So let me open. I already have this file. I've written this file called Hello World, and it has some text in it. So there are some letters, space, exclamation point, 2 lines of text, and that's how I see it when I open it with my text editor, Vim. That would be the same if I used Gedit, okay? Hello World, okay? So it would open a separate, that's a separate editor. It's like Notepad++ or Notepad, okay? Just a very simple editor. It shows the text. I could edit it, save it, whatnot. It also shows 2 lines, okay? So that's how I see it when I open it with a tool. There is also this cat command on Linux that I could use that would just print out the content of the file, and you can see the first line, the second line. Well, the prompt is immediately after the end of the second line. It doesn't go to the new line. Doesn't matter in this case, but that's how the file is saved and how that's being shown by you. By the way, if you're using Windows, then instead of cat, you would use the type command. So you would say type in the word type and the name of the file, and it would show you the content of the file on the command line. So that's how it's used, but you can actually, there's another tool that can show you how the content of this file is actually on the disk, and that tool is called XXD on Linux, and I think it's also available on Mac. On Windows, I'm not sure. I'm quite sure that there is something. I don't know if XXD is the one that you could install. So I run this XXD and give it the name of the file, and it will show me the content of the file in a slightly different way now, because this is the default way to show it, but it's going to be easier to give some parameters to this XXD to show it in a slightly different way. So I tell it to C1 to show only one item, 1 byte on every row, and I'm also telling it to show it with decimal indexing. So now it looks slightly different. It's basically the same, just in a more columnar representation. So what we see in this representation is this is just an index, the serial number of the character of the byte actually that's in the file. So that's I have to tell a little bit about this. So a character is a drawing, what you see on the screen, the letter A, the exclamation mark, maybe an emoji, something that's called a character or a glyph. These are the sort of synonyms. A byte is something that can store a number between 0 and 255 in the disk, on the disk. But because there are more characters, more glyphs than could fit in these numbers, 0 to 255, some characters are going to be represented by more than 1 byte. So what this program shows is actually the series of bytes that are on the disk. So this is the first byte, this is the second byte, and it's indexed 0, 1, 2, and so on. So this is just the location, the first column. Then the next one is the hexadecimal representation of this number. So 48 would mean 4 times 16 plus 8. And that would be the hexadecimal representation of this number. And this is the character that was represented by that number. So 48, remember that's hexadecimal 48, represents the capital letter H. And we can let's see, there's a browser window open somewhere here. So first of all, this mapping from characters to these numbers is called the Unicode mapping, okay? And more specifically, what I have on the disk is a specific representation of this Unicode mapping, which is called UTF-8. It's somewhere there. Here's UTF-8, okay? There are other representations of this, but this is the most common one, and this is what I'm going to show. And there is another page on Wikipedia and the links are below the video, or there's a link below the video that leads to the page where are all the links and the article. There's another page on Wikipedia with the list of Unicode characters. This is a subset of the characters. Obviously, there are way more than I think can be shown on this page. And then I found this separate site, which is called unicodetable.com, where you can actually type in some Unicode letter or character, and it will show you the value. So what I see is there's a letter H, so capital letter H. So I type in here, and it's Latin capital letter H. And it shows the details. And what I scroll down here, maybe I'll enlarge a little bit, and what I can see is the UTF-8 is the hexa 48. Okay, so remember, this is the exact 48 that we saw here, and in decimal that's 72. So it's basically 6 times 4, which is 64, plus 8, that's 72. Okay, that's the decimal representation of this. And then there's also the binary representation. That's not really important for us. I'm saying the decimal representation because those are the types of numbers we are more familiar with. Okay, so some people live in hexa, I not so much, but well, whatever. Okay, so the first character was the H. Okay, and remember that the text is hello world, the first line, and then the next is E, the lowercase e. So that's represented with 65 hexa. So I can come here again and type in the E, Latin small letter, okay, lowercase, small, whatever. Here you can see that in UTF-8 it's hexa 65 or 65, and yeah, I'm going to accept these cookies, whatever. And the decimal 101. So the 65 or 65 is what you can see here. So these are the regular letters, and then which are normal, okay? But you can see that each letter, okay, each letter, Latin letter, has a number representation. There is the space, so this is the location of the space, okay, from the hello world, and it is represented by the hexa 20. So it's 20, which is 32. And I don't know if this can, I haven't tried this one, so what if I press in space? Yeah, okay, it found something. Okay, so that's 20. Okay, so you can see that's 20 or decimal 32. That's the space. Good. Then capital W, world. Okay, so the next interesting one is the exclamation mark, which is 21. So here you can also type in exclamation mark, and that's what we get. Okay, 21 decimal 30. So the next thing is interesting because here we have a dot. But we don't have in our text, in our original text, if I scroll up a little bit, well, I can just run cat on this so you can see. So after the exclamation mark, there's no dot. It just goes to the next line. So because this XXD can't really represent new line or something that goes to the new line, that's why instead of that, it represents it shows here a dot. And there are a number of these characters that can't be really shown because they are instructions to the computer. For example, there is one called the bell that would ring the bell in the computer. But there are others. And the one that we are seeing here is the character, which is called line feed. Okay, and that's the numeral representation, 08 or just 8, which is in decimal 10. And because it can't be really represented, shown on the screen, that's why this program, the XXD, just puts there a dot, okay, because it can't translate this into something that can be shown nicely. When you use any other program, basically, so cat or the editors, then it will translate this character, this number, this 08, into the meaning that the next thing should be shown or must be shown on the next line of the page. So that's why after the exclamation mark, the next character, the capital H, is shown on the next line because of this number. And this is slightly different in Windows, but I don't get into that now. I'm using Linux here primarily because that's what I have on my computer, but it's also easier to show these things here on Linux. So the next thing would be the capital H, which is just regular, and then we have some bare space and more space and an exclamation mark. So that's fine, that's easy. And then we are done with the regular Latin letters and the regular extra characters, the punctuations like exclamation mark, semicolon, whatever, these are all fit in this category or space, and that's all. But what happens if you are dealing with text that are not confined to these letters? For example, Hungarian. So let's see this one. I prepared a file with the Hungarian vowels. So in English, you use 5 vowels, the A, E, I, O, U, but actually you say all kind of sounds. You make all kind of sounds depending on how they are put together in a word, which country are you from, and whatnot, okay? In Hungarian, as opposed to this, there are actually 14 vowels. These are the 14 vowels. And the Hungarians usually say exactly those 14 sounds. There are slight differences based on location in Hungary or slightly elsewhere around Hungary, depending on where you are from. But the variations are really tiny. So each vowel has its own sound. But well, that's not the interesting part for us now. The interesting part is how to represent this on the disk. So these are the 14 vowels, which I will just say now. So O, that would be O, A, E, I, O, U, U, U. So just to have learned a little bit of Hungarian as well. Okay, so this is how it looks like. I can also use cat to show this, and you can see them here at the bottom of the screen. And once I run the XXD, it will go up to the top of the screen, and then it might be easier to see. So now I run XXD on this file, the Hungarian, okay? So now here you can first of all see the output of cat, just so it will have our representation. Just we'll be able to see it. And then how does it seen? How is it shown, or how is it saved in the file? So the A letter, the letter A is easy, just regular Latin letter. It's 61, just as we see so earlier. So I can type here the letter A, Latin character table, Latin small letter, okay, A. And that says hexa 61 or decimal 91. That's fine. The next one is already slightly more difficult. So I try to copy it from here. Let's see if I can manage to copy it. Okay, so this is it's 2 characters already, as you can see. It's C3 and A1, and because this 2 bytes, sorry. Okay, so this character, okay, just to clear up the wording, this character, the A character in Hungarian A, is represented by 2 numbers, 2 bytes, C3 and A1, and because neither of them alone are a real byte, real character, that's why this, these are both bytes, but they are not real characters on their own, as they are saved in this file. So because of this, the XXD represents them with 2 dots, because it doesn't put them together. If I come here and search here, either by typing in the letter or by copy pasting it from somewhere, so it says Latin small letter with an acute. Okay, that's the official name of it apparently. And as you can see, it is in UTF-8, it's represented with C3 and A1. And exactly what I see here, C3 and A1. And just to clarify something here, using lowercase like here, C and A, or uppercase C and A doesn't really matter in hexadecimal. Okay, you can use either one. You usually use the same lowercase or uppercase in the context, but it doesn't really matter. Okay, so this is the hexa, and these would be the converted to decimal numbers, and together, because at the end this is 16 times 195 plus 161. That's the number. So this is the result of that number. This is the value, the decimal value of this character in the UTF-8 table. So this is how, when you type in a letter, an A letter in Hungarian, that character, it will be saved as C3 and A1 on the disk. Okay, and then the next one is an E, which is a Latin letter, that's easy, 64. The next one is A, which is the E with an accent mark. So you can come here and type it here. So I switch to Hungarian keyboard and I type in this one. So this one says that it's C3A9, and it's in C3A9. That's what we have on the disk. So that way you can see that all the letters or the characters, glyphs, these are synonyms, okay, have their own number, and this is how they are stored on the disk. Okay, so that's Hungarian. Now there is also Spanish. So Spanish, just to show you. So in Spanish you have this ñ, okay, which is a special character, and I can use XXD on this one. So this is the representation of the Spanish. Sorry, I ran on the Hungarian. Spanish. Okay, so this is the Spanish text, and this is the actual text here at the bottom. Okay, so that's where you can see mañana, and here the letters. So here you can see that the ñ is represented by C3 and B1, and I can check this out here if I type here and switch to Spanish, type in the Spanish letter, and then this is what I found. And here you can see that C3B1. Okay, so this is exactly what I saw here. Okay, so these are this is the vocabulary of the languages that use Latin letters plus all kind of extra characters. Some are apostrophes, some are the tilde for mañana, some are Norwegian and Danish have these various letters with all kind of things, and Czech. So most of the European languages actually have some extra character. But there are other languages, Chinese, Korean, Japanese, Thai, Urdu, whatever, with all kind of other letters. And I'm not really expert on any of these, so I don't know any of them, in other words, so I can't show you this, but I can show you in Hebrew. So, and that's extra fun, because Hebrew or Arabic or Farsi, they are not only using different alphabet, they are also written from right to left. So let's see what shows, what do we have here. So if I open this text, which was written in Hebrew, so it says Shalom Olam. And the fun thing is that though I typed in the letter Shin first, that's on the right hand side. Okay, so this is the first letter because this is written from the right to left. So what happens if I try to use cat on this? And here it also shows it correctly. So those who are not reading Hebrew, well, I can assure you that this is in the right direction. And now I can use the cat, not the cat, sorry, the XXD for the Hebrew text. And it's all dots, of course, okay? Because it can't show any of the Hebrew characters, because all of the Hebrew characters are actually represented by more than one bytes. So I take the first character, which is Shin, okay? If I manage to, I can't copy it from here. So, well, I'm going just to type here in. So I switch to the Hebrew keyboard and I type in Shin, the Hebrew letter Shin, okay? And that's what you get here. This is the first letter in that text. And you can see that the representation is D7A9. So it's D7A9. So that was the actually first letter written in the file. But it's when it's shown by your whatever program, whether it's CAT or the editor, or then it would be shown on the right hand side. And this is a whole separate kind of worms of how do you represent, or how it's being represented, or how it's being saved if you have some Hebrew text from the right to left, and then let's say some numbers in there, which goes from the left to right. So it's the other direction. And then maybe also have some other text in some other languages, which also go from the left to right. So how is it all saved in a file, and how is it being represented then and shown? And well, people who read and write Hebrew or Arabic or Persian, I'm sure they are all aware of all these problems that they encounter in most of the environments. Okay, it's not an easy thing. So this is text that goes from the right to left, and all the other letters are similar. You can see them, look up them in Unicode table. Okay, and the last example I wanted to show you is this. So okay, I was writing in Hebrew. Let's edit it and write in this is the file, emojis. Okay, so I put here a couple of emojis in this file. Okay, I copied it from somewhere. Okay, I can edit it with the editor, let's see what does gedit say on this. Gedit, well, it also shows the emojis, nice. And I can also use cat to print them out on the screen so you can see them there. And I can use XXD with the emojis, and I get a long list. Okay, so let's pick up the first one, which I'm going to copy paste from here, and copied it from the command line and pasted it here. Apparently it's called a construction worker. Well, it's not that surprising. It looks like a construction worker. And if I scroll down, I don't know what are all these other things. Okay, so you want to read about that, fine. But you can see here that the hex representation of this is actually 4 bytes. So, well, that's more rare of things. So it starts with F09F. And if I come back here, F09F and then 91B7. So it's 91B7. So this is exactly really what we see here in the first 4 bytes of this file. We see the representation of this emoji, of this character. As a decimal number, this is the decimal value of this. So each one of these 2 characters or 2 things, 2 whatever, okay, is a hexadecimal number. These are the zeros, these are the 16s. So this is 15, F is 15. So 15 times 16, that's 240, apparently. I don't make the calculations. And then all the rest are calculated here. And then you multiply them even more. So you say it's 183 plus 16 times 145 plus 16 square times 159 plus 16 on the third times 240. And that's I guess is the number. Okay, so this is the decimal value of this character. And then you can see the rest. So you can see that if you're writing emojis, it will take up, each emoji will take up 4 bytes in the file. And then every tool should, they not always do this, but every tool should be able to understand that when there is a character called F0, then the next 3 is part of it, okay? And that is going to be a single character. And then knows from the Unicode table, from UTF-8 and Unicode tables, will know what drawing to show. And actually, that's something that, so what you can see here, I guess, is how each of these characters are actually represented by different vendors, operating system, whatnot. So you can see that on Apple, this looks like this, on Google looks slightly differently, Facebook slightly differently, and so on, okay? So how the drawing looks like is not necessarily the same on every page, but they have the common number. So I think that's it. I've covered everything I wanted. There are a lot more to say about representing text in files, but it's already way too much now. So I just stop the share and stop the video. So thank you for watching so far. If you like this, if you think that it's useful, then please also like the video and follow the channel so you get updated for the upcoming videos. There's this bell that you can click on so you will get the notification. So thank you and see you next time.